Night falls over Kyushu, Japan, December 1944. The sky is fractured by searchlights and fire. High above, a formation of silver giants crosses the darkness. Boeing B-29 superfortresses, the most advanced bombers the world has ever seen. Their engines thunder like rolling earthquakes, their shadows sweeping over the rice fields below. Anti-aircraft batteries erupt, sending orange tracers into the clouds. One finds its mark, a single B-29 shudders. Flames pour from its right wing as it breaks formation, spiraling downward. Its crew fights to keep control, but the fire grows. The massive aircraft, a marvel of American engineering, becomes a falling sun, its glow reflected on the snow-dusted hills. Moments later, an explosion. A blast echoes across the valley near Yawata, scattering metal across the frozen ground. When dawn arrives, a team of Japanese Army engineers approaches the wreckage. Smoke still rises from the twisted frame. The smell of burned aluminum and aviation fuel fills the air. They expected to find a bomber like any other. What they found instead would shock Japan's military and reshape its understanding of the war itself. By late 1944, Japan's war machine was collapsing under the weight of industrial exhaustion and Allied supremacy in the Pacific. The empire had expanded too far, too fast, from the jungles of Burma to the islands of the Central Pacific. And now, the tide was reversing. American forces were advancing island by island, capturing airfields that brought the Japanese homeland within reach. Yet even as Japan fought desperately to hold its perimeter, a new kind of threat appeared on the horizon, a weapon that didn't need to land, didn't need a fleet, and could strike from altitudes no Japanese interceptor could touch. That weapon was the Boeing B-29 Superfortress. Developed at a staggering cost and more than $3 billion in wartime dollars. The B-29 represented the absolute peak of American industrial and scientific power. It was an aircraft built not just to win battles, but to redefine how wars were fought. With a pressurized cabin, remote-controlled gun turrets, and engines capable of lifting it 30,000 feet into the sky, it was a machine decades ahead of its time. When the first squadrons of B-29s began their missions from bases in India and China in mid-1944, the results were limited. Logistics were punishing and Japanese defenses remained largely intact. But once the United States captured the Mariana Islands, Saipan, Tinian, and Guam, everything changed. From these islands, B-29s could now reach the Japanese mainland. Thousands of miles of ocean no longer protected Japan. Factories, shipyards, and refineries were suddenly within range. American planners understood the significance. The 20th Air Force, commanded by General Curtis LeMay, was created specifically for the task of crushing Japan's industrial capacity from the air. Unlike Europe, where bombers targeted specific factories, the mission in Japan was broader: to unmake a war economy by destroying its heart, the cities themselves. Japanese military intelligence had heard rumors of this super fortress. Reports described it as enormous, heavily armed and nearly impossible to shoot down, but in Tokyo's war offices, many dismissed it as American propaganda. They believed Japan's air defenses, the Ki-43 Oscars and Ki-61 Tonys, along with their network of anti-aircraft guns, would be sufficient. Then the first B-29 raids arrived over Kyushu and Honshu. They flew higher than any interceptor could reach. Their formation seemed untouchable, their speed unmatched. Even when one was damaged, it often managed to limp home across hundreds of miles of ocean, a testament to its engineering strength. But on that December night near Yawata, one of those giants didn't make it back. When Japanese recovery teams arrived the next morning, they found the aircraft scattered across a wide area, a mix of crushed aluminum, melted steel, and shattered perspex. Among the wreckage were pieces of machinery no one had ever seen before. Hydraulic systems unlike any used by the Imperial Japanese Army, thick cables coated with synthetic insulation, and a turret system that moved automatically, without a visible gunner. To the engineers, it was immediately clear. This was not just a bomber. This was a flying laboratory, designed by a nation whose industry operated at a level Japan could no longer hope to match. The discovery was immediately reported to Imperial General Headquarters in Tokyo. Orders came down: recover everything, study everything, Understand how this machine flies. The team that gathered at Yawata included the best aviation minds in Japan, men from Nakajima, Mitsubishi, and the Army Aerotechnical Research Institute. They began the careful process of examining the remains, sketching components, and documenting every surviving system. And within hours, the shock began to set in. They realized the B-29 was not an evolution of conventional bombers like the Japanese Kai-67 or G-4M Betty. It was an entirely new species of war machine. Its fuselage construction was seamless, its control systems electric rather than purely mechanical, and its pressurized cabin allowed crews to fly comfortably at heights no Japanese pilot could endure without oxygen masks freezing solid. It was not merely superior, it was untouchable. And for the Japanese, engineers crouched in the cold mud of Kyushu that morning, one question began to echo in their minds. How could any nation build something this advanced and build thousands of them? The answer, they would soon discover, lay not just in the machine before them, but in the industrial empire behind it. The wreckage from Yawata was carefully packed into wooden crates and transported under heavy guard to Tachikawa, the heart of Japan's wartime aeronautical research. There, inside hangars belonging to the Army Aerotechnical Research Institute, the fragments were laid out across vast tables, wings, fuselage panels, and blackened remnants of its engines. Each piece told a story that Japan's scientists had not been prepared to hear. The first revelation came from the materials themselves. The aluminum alloy used in the B-29 structure was stronger, lighter, and more heat-resistant than anything produced in Japan. When tested, it revealed a composition Japan's metallurgists could not replicate. The U.S. had developed advanced duralumin and alclad coatings that resisted corrosion, even in extreme conditions. Japanese factories, strained by shortages and Allied blockades, were still using lower-grade metals recycled from civilian sources. Then came the engines. 4 massive Wright R-3350 duplex Cyclone engines, each producing over 2,200 horsepower, had powered this single bomber. Even in pieces, they were masterpieces of engineering, a labyrinth of pistons, valves, and cooling systems beyond anything Japan's industry could match. The R-3350 used materials and designs Japan could not mass-produce: nickel alloys, precision-machined superchargers, and intricate fuel injection systems. Japanese engineers had been struggling to keep their own aircraft flying. Many of their engines overheated, leaked oil, or simply wore out after a few dozen flight hours. The R-3350 was built to fly across an ocean, bomb a continent, and return home again. Next came the systems that truly defied understanding. The engineers found electrical wiring harnesses thicker than anything they'd seen, insulated with synthetic rubber compounds Japan could not produce at scale. And then, the discovery that changed everything: the central fire control system. At first glance, it looked like a collection of motors and gyros connected to the turrets. But once the engineers traced the wiring, they realized what it was: a computerized aiming system controlled remotely by gunners inside the pressurized cabin. Each gunner could control multiple turrets at once, the system automatically compensating for altitude, airspeed, and target movement. Japan's best minds were stunned. Until that moment, their bombers had relied on manual aiming, simple ring sights or telescopic guns. The idea that a machine could perform ballistic calculations in real time automatically seemed almost unbelievable. The B-29's pressurized cabin was another marvel. Its interior design, recovered partially intact, showed insulation, heating ducts, and oxygen systems integrated seamlessly into the fuselage. For the Japanese, whose bombers still used unpressurized freezing cockpits, this was a revelation. It allowed American crews to fly higher, farther, and longer, without fatigue or frostbite. But perhaps the most sobering realization came not from what the engineers saw, but from what they didn't. When they examined the rivets, welds, and joints, they found a consistency that could only come from machine precision, not handcrafting. This bomber had been built by the thousands, every component identical. It was the signature of industrial automation, an assembly line miracle Japan could not dream of matching under constant bombing and resource starvation. Within weeks, detailed reports of the examination reached Tokyo. The findings horrified Japan's senior leadership. The B-29 wasn't just a weapon, It was a symbol of what Japan lacked: industrial depth, scientific integration, and resource abundance. The empire's own engineers tried to replicate what they could. They experimented with improved alloys, refined turbochargers, and copied parts of the B-29's fire control system. But the scale of American innovation was overwhelming. While Japan could barely produce a few dozen advanced aircraft per month, American factories in Wichita, Marietta, and Seattle were rolling out B-29s at the rate of 4 per day. Every single one was equipped with technologies Japan could barely understand. The shock among Japan's engineers turned into a grim acceptance. They were no longer fighting a war of soldiers and pilots. They were fighting a war of machines, and America's machines were winning. By early 1945, as more B-29s arrived over the skies of Tokyo, Osaka, and Nagoya, the same men who had once studied that wreckage could now identify each sound, each formation, each bomb pattern. They knew exactly what was coming, and knew there was nothing left to stop it. The engineers' reports would later serve another purpose, not to help Japan win the war, but to help it understand how it lost. The wreckage of the B-29 at Yawata did not just reveal technology. It revealed perspectives, contrasting worlds of war and industry, science and desperation. Each angle told a different part of the same story, how two nations saw the same sky through entirely different eyes. The Japanese engineers, shock in the cold light of morning, they first men to touch the wreckage were from the Army Aerotechnical Research Institute and Nakajima Aircraft Company, Japan's top aviation minds. They had built aircraft like the Kai-84 Hayate, the most advanced fighter in the Imperial Army's arsenal, yet compared to what lay before them, even the Hayate felt primitive. They examined the wiring, rivets, and turrets in silence. Each new discovery struck like a blow. Electric servo motors where they had used cables and pulleys, hydraulic systems with redundancy layers they had never designed, and materials that remained intact after an inferno. Lieutenant Engineer Shigeyuki Suzuki, who had worked on Japan's own high-altitude bomber project, reportedly remarked that the B-29 was a weapon designed by a nation that had mastered not only air combat, but production itself. They realized America was not fighting one war. It was fighting 1,000 smaller wars, one in the laboratory, one in the factory, one in the logistics chain. Japan had brave pilots and brilliant designers, but America had systems, self-sustaining, self-feeding, and endlessly scalable. That was the true shock of the B-29. It wasn't a miracle of genius, but of organization. A nation at war that never stopped producing, never stopped improving. The American designers, engineering for victory thousands of miles away, at the Boeing plant in Wichita, Kansas, engineers and draftsmen had spent years solving the problems that stunned Japan's best scientists. They weren't magicians. They were engineers driven by time, pressure, and national will. The B-29 had been conceived in 1939, before America even entered the war. Its purpose was clear from the start: to strike deep into enemy territory, beyond fighter range, with payloads no previous aircraft could carry. Every problem that limited earlier bombers, altitude, range, crew fatigue, was systematically solved. When the first prototypes rolled out in 1942, the aircraft was already a technological leap forward: a pressurized fuselage, central fire control, remote turrets, high-efficiency engines, and an unprecedented bomb capacity of 20,000 pounds. But the cost of this innovation was staggering. Boeing's engineers battled constant engine fires, pressure leaks, and design flaws. Test flights ended in tragedy. Dozens of aircraft were lost during trials. Yet the U.S. did something Japan could not afford. It learned from failure at scale. Each crash meant more data, more redesigns, more funding. In Japan, every lost prototype was a national setback. In America, it was just another experiment. By 1944, the aircraft was perfected enough to fly missions from India and then from the Mariana Islands. Its success was not inevitable. It was manufactured through persistence, infrastructure, and an industrial mindset Japan could not replicate. The factory workers, America's invisible army, while the Japanese engineers examined the wreckage, They unknowingly studied the handiwork of hundreds of thousands of American civilians. The B-29 was not built by a single company, but by an entire nation. In Kansas, Washington, and Georgia, assembly lines ran day and night. Entire cities revolved around bomber production. Wichita alone employed over 160,000 workers, most of them women. They riveted, welded, tested, and inspected without rest. These workers became a silent part of the war front. While soldiers fought in Europe and the Pacific, they fought a different kind of battle, one of endurance, precision, and speed. Each B-29 required over 140,000 separate parts and 900,000 rivets. To meet demand, America built new factories the size of entire Japanese towns. They introduced mass tooling, conveyor assembly, and standardized components across states. When a B-29 was completed, it carried within its frame the effort of 1 million hands, miners, mechanics, machinists, chemists. It was more than a bomber. It was a manifestation of collective labor. The Japanese engineers studying the wreckage would later note something remarkable. Every component bore the same stamped code numbers, indicating uniformity across production batches. They understood what that meant. The U.S. was not building bombers one at a time. It was producing them like automobiles. The strategic commanders, turning industry into a weapon behind the engineering triumph, stood the men who turned it into strategy. General Henry Hap Arnold, commander of the U.S. Army Air Forces, had been the driving force behind the B-29's creation. He envisioned it as more than an aircraft. It was the foundation of a new kind of warfare. Arnold knew America's strength lay not only in its factories but in its ability to deliver that power anywhere on Earth. The B-29 made that vision real. It could carry 10 tons of bombs over 3,000 miles at altitudes above 30,000 feet, beyond the reach of most anti-aircraft guns. To Japan's generals, this seemed impossible. To Arnold, it was simply a matter of willpower and logistics. By creating air bases across the Pacific, first in China, then in the Marianas, he effectively erased the limits of geography. The bomber became the tool that connected America's industrial might directly to Japan's cities. When the first waves of B-29s appeared over Tokyo, they were not just aircraft. They were the physical embodiment of strategy made metal, the idea that distance and isolation could no longer protect an empire. The engineers in Kyushu didn't yet know it, but the machine they studied would soon rewrite their nation's future, not only through destruction but through transformation. The discovery of the B-29's wreckage didn't just challenge Japan's engineers. It shook the entire military establishment, from generals to factory workers. Each group saw the same machine through a different lens: technological, moral, and existential. It was no longer simply about an aircraft. It was about what it meant. The Japanese High Command, realizing the scale of defeat, when the technical reports from Tachikawa reached Imperial General Headquarters in Tokyo, they landed with a quiet sense of dread. Generals who had once spoken confidently of repelling any air raid now read the words unprecedented altitude, electrical control, and pressurized flight. For the first time, they faced the reality that Japan was fighting a war it could not technologically sustain. Until then, the military had believed that courage and training could balance the scales, that spirit could overcome machinery. But the B-29 proved otherwise. Even if Japan built a bomber of similar design, it could never build enough of them. Even if they improved engines, they lacked the oil to fuel them. And even if they trained pilots for high-altitude missions, they lacked the oxygen equipment and infrastructure to sustain such flights. The B-29 revealed a truth Japan had long resisted. Modern war was no longer a test of bravery alone. It was a contest of systems, and the American system was colossal. One general famously remarked during an internal meeting, "The enemy does not sleep. They build while they fight." And indeed, that was the ultimate shock, that America could fight a global war while producing more aircraft, ships, and weapons than the entire Axis combined. The civilians, hearing the sky before seeing it, while the generals studied reports, ordinary Japanese citizens learned about the B-29 in a different way, through fear. By the end of 1944, its deep-engine drone became an omen. Children in Tokyo and Nagoya could identify it instantly. a slow, resonant hum that meant the bomb shelters would soon fill. To them, the B-29 seemed supernatural. It flew higher than the eye could see, beyond the reach of Japanese fighters. Sometimes the sky was clear, yet the sound remained distant, heavy, unstoppable. For civilians, this was not technology. It was fate. Newspapers tried to portray the bombers as clumsy giants, vulnerable to Japan's spirit and skill. But when bombs began falling in precision patterns, burning entire city blocks, the propaganda began to crumble. The Japanese home front had once believed in victory through sacrifice, but the sight of cities reduced to ash from an enemy that never even entered the horizon created a new kind of despair, one that courage could not erase. The B-29 was not simply a machine of destruction. It was a psychological weapon, proof that American power could reach anywhere, anytime, without warning. The scientists, a glimpse into another world. At the universities in Tokyo and Nagoya, professors of metallurgy, physics, and aerodynamics were invited to study fragments of the B-29 systems. To them, it was like opening a window into the future. They found technologies that hinted at a different kind of civilization, one where universities, industries, and the military worked together seamlessly. In Japan, such collaboration was hindered by secrecy, rivalry, and lack of resources. But in America, it appeared to be unified, all parts contributing to the same goal. Materials scientist at the University of Tokyo reportedly remarked that the aluminum alloy used in the bomber might as well have been born from another planet. The synthetic rubber insulation, the electrical gyros, even the paint coatings, all revealed chemical processes Japan had no means to replicate. For these scientists, the discovery was humbling but also illuminating. They began to see that the true strength of a nation was not just its weapons, but its scientific culture, the ability to innovate faster than war could destroy. Some of these same men would later help rebuild Japan's post-war industry, inspired not by resentment, but by what they had learned from studying their enemy's brilliance. The enemy pilots, respect in the sky while Japanese engineers studied wreckage. Their pilots faced the B-29s directly and learned to fear them. Fighters like the Ki-84 Hayate and Ki-61 Hien could sometimes climb high enough to intercept. But the B-29 formations flew at altitudes around 30,000 feet, escorted by P-51 Mustangs by mid-1945. Even when Japanese fighters broke through, their machine guns often failed to do lasting damage. The bombers' remote turrets fired streams of 50 caliber rounds guided by computing sites, making approach from any angle deadly. Those who survived attacks reported seeing B-29s maintain formation even as flames licked from their engines, massive aircraft refusing to fall. To the Japanese pilots, it became a symbol of the enemy's endurance, a mechanical reflection of the American soldiers' willpower. By the final months of the war, Japanese squadrons had resorted to ramming tactics, kamikaze-style attacks against the superfortresses. Even then, few succeeded in stopping the waves. The moral angle, war by numbers. For some within Japan's government and scientific circles, the most haunting realization came later, not about the bomber's power, but about its meaning. The B-29 was the first aircraft designed from the ground up for strategic destruction, to erase entire cities rather than fight armies. It marked a turning point in warfare, victory not through battle, but through industrial annihilation. When the engineers looked upon that wreckage at Yawata, they saw their nation's reflection, a country that had tried to conquer the modern world with the weapons of the past. The B-29 was the machine that ended that illusion. It would go on to drop not only fire over Tokyo, but ultimately the atomic bombs over Hiroshima and Nagasaki. In that sense, the story of the wreckage was more than technical curiosity. It was the prelude to a transformation in human warfare. For Japan's surviving scientists and officers, the lesson was clear. The age of courage had ended. The age of technology and total industry had begun. The engineers who once touched the cold metal of the fallen B-29 did not yet know what was coming. But in their hands lay the blueprint of the future, both the cause of their nation's collapse and the foundation of its rebirth. Tokyo, night of March 9, 1945. The air was still, unnervingly quiet. Beneath the cover of darkness, a vast industrial city, the beating heart of Japan's war machine, slept in uneasy silence. Workers had returned from the factories that built engines and weapons for a war few still believed could be won. Then, at 10:30 p.m., the low hum began. It wasn't thunder. It was hundreds of miles away, approaching fast. The sound of hundreds of Boeing B-29 superfortresses cutting through the sky. They came not in daylight this time, but at night flying low, their bomb bays loaded not with explosives, but with fire, the arrival of hellfire. At 12:08 a.m., the first flares fell. They burst above Tokyo's eastern wards, illuminating wooden rooftops and narrow alleys like ghostly lanterns. Moments later came the first cluster bombs, M69 incendiaries designed to scatter and ignite on impact. Within minutes, the old capital began to burn. Fire raced along the wooden streets faster than anyone could run. Oxygen vanished from the alleys as people gasped for breath. The wind, a steady 15 miles per hour, turned the city into a furnace. More than 279 B-29s flew over that night, led by General Curtis LeMay's 21 Bomber Command. Their mission was clear: to break Japan's capacity and will to fight by burning its cities to ash. The bombers flew in staggered waves for over 2 hours, dropping nearly 1,700 tons of napalm and incendiaries. Entire districts of Fukagawa, Honjo, Koto disappeared beneath sheets of flame. From above, the crews saw the inferno spread like a living organism, consuming everything. One pilot later said, "It was as if the earth itself had caught fire." The Japanese response, Hopeless Altitude, Japan's air defense network, designed for high-altitude interception, was paralyzed. When the bombers had first appeared months earlier, the Imperial Army Air Force expected them to fly at 30,000 feet, beyond the reach of most Japanese fighters. But LeMay had changed tactics. Now the B-29s flew at 5,000 to 9,000 feet, low enough for precision, too low for radar to respond quickly. The night raids caught the defenders completely off guard. Anti-aircraft guns fired blindly into the red sky. The tracer rounds vanished into clouds of smoke and flame. Fighter squadrons scrambled too late, their pilots disoriented by the blacked-out city and suffocating heat below. On the ground, the Air Defense Command's radio communications broke down. Reports from observers came in fragments, hundreds of planes and city burning, no contact. Inside command posts, officers listened helplessly to static and distant explosions, knowing there was nothing left to send. The city that vanished. By 2:30 a.m., entire neighborhoods were gone. Wooden homes, paper walls, and tatami floors became fuel for the inferno. The heat reached over 1,800 degrees Fahrenheit, melting glass, warping metal and turning rivers into boiling streams. Tens of thousands fled toward the Sumida River, hoping to escape the flames. But when they reached the banks, they found it glowing with firebombs and burning oil. Many jumped in, only to drown beneath collapsing bridges or suffocate in the steam. Eyewitnesses would later recall seeing people turned to ash where they stood. Others caught in the firestorm were lifted off their feet by the sheer force of rising heat and wind. Above, American pilots saw only light, a sea of flame so bright it could be seen 150 miles away, even from the B-29s retreating over the Pacific. When the sun rose, Tokyo no longer looked like a city. It was a wasteland of smoldering ruins stretching for miles. Over 100,000 people were dead, more than in any single bombing of the war before Hiroshima. 1/4 of the capital's structures were gone, and among those who later walked the ruins were the same Japanese engineers who had once studied the wreckage of the B-29. Now, they saw the weapon not as a piece of machinery, but as the instrument of their nation's destruction, the confirmation of power in military headquarters. The surviving officers read the first reports of the raid with disbelief. The city's air defenses had destroyed only 14 bombers. The rest had returned safely to the Marianas, 500 miles away, to refuel and rearm. That night, every illusion of parity vanished. The engineers' earlier analysis, that Japan could not match American production, materials, or engineering, was no longer theoretical. It was written in fire across the capital of the empire. Within days, the same strategy would be repeated against Nagoya, Osaka, Kobe, and Yokohama. Each night more cities disappeared. The Japanese industrial heartland, small workshops, armories, and civilian labor was systematically erased. And from the Marianas, the B-29s kept coming, thousands strong, their silver wings reflecting the dawn light over the Pacific. What the engineers had once studied as fragments of a downed enemy now ruled the sky completely. And deep down, every officer knew there was no weapon in Japan's arsenal that could stop it. The next evolution of this power would not be fire, but something far more devastating, and it would again arrive from the belly of a B-29. August 1945. The Pacific War was nearing its end, but Japan did not yet know it. The cities had burned, the Air Force had shattered, the Navy was gone. Still the High Command refused to surrender, and then came the next wave, not of hundreds but of a few aircraft that carried the power to end civilizations. At the heart of it all, the same machine the engineers had once studied in disbelief, the Boeing B-29 Superfortress. The aircraft of the end in the pre-dawn hours of August 6, 1945. At Northfield on Tinian Island, a B-29 named Enola Gay prepared for takeoff. Its crew of 12 stood silently as final checks were completed. In its bomb bay hung a single weapon unlike any before it. Little Boy, a uranium-based atomic bomb weighing over 9,000 pounds. At 2:45 a.m., the bomber's engines roared to life. It lifted from the coral runway, its silver body glinting under the stars. The flight path was precise, across the Pacific over Iwo Jima, and on toward a city that had so far been untouched, Hiroshima. At 8:15 a.m., from an altitude of 31,000 feet, the bomb bay doors opened. 43 seconds later, the world changed forever. The explosion unleashed the energy of 15,000 tons of TNT. A blinding white flash lit the sky. In less than a second, the city vanished beneath a rising column of fire and dust. Buildings evaporated. People's shadows burned into the pavement. The temperature at ground zero exceeded 4,000 degrees Celsius. 70,000 people died instantly. Tens of thousands more would follow in the days ahead. Above the destruction, Enola Gay banked away, its crew watching the mushroom cloud rise into history. In that moment, the B-29 became not only a weapon of war, but a messenger of apocalypse. The final message. Nagasaki 3 days later. On August 9th, another B-29 boxcar took off, carrying the second bomb, Fat Man. Its target, the industrial port city of Kokura, but heavy cloud cover obscured the sight. After 3 failed passes, the pilot made a fateful decision to divert to the secondary target, Nagasaki. At 11:02 a.m., the bomb fell. The resulting explosion was even more powerful than Hiroshima's. Entire neighborhoods disappeared in seconds. More than 70,000 people were dead or wounded. In both missions, Japanese radar detected the bombers, but no interceptors reached them. The few fighters still operational had neither the altitude capability nor the fuel to pursue. The once feared B-29s flew unchallenged to their targets and returned safely. To the Japanese leadership, this was the final confirmation. Their empire was finished. The realization of defeat in the underground shelters of Imperial General Headquarters, silence filled the war rooms. Reports from Hiroshima and Nagasaki arrived in fragments. Total destruction, no survivors, unknown weapon. The scientists who examined the aftereffects quickly recognized what it meant. They had heard rumors of nuclear research in the West. Now, standing in the ruins of 2 vanished cities, they saw its results with their own eyes. The B-29 had not merely defeated Japan's defenses, it had carried the future of warfare itself, a future built on science, scale, and relentless industrial progress. On August 15, 1945, Emperor Hirohito's voice reached the Japanese people for the first time. In a trembling broadcast, he announced the surrender, saying, "The enemy has begun to employ a new and most cruel bomb." For those who had once studied the wreckage of the first B-29, the irony was inescapable. That same aircraft, the one that had inspired awe, fear, and admiration, had now delivered the weapon that ended their nation's war. The symbol of total war by war's end, the United States had built nearly 4,000 B-29 superfortresses. They flew from the Marianas, China, and India. They dropped over 170,000 tons of bombs on Japan, more than any campaign in history. The B-29 was not the fastest plane, not the most agile, but it embodied something larger, a nation's industrial will. Each bomber represented the labor of thousands, factory workers, engineers, scientists, and assembly line welders working day and night across the American heartland. It was this system, not just the aircraft, that had stunned the Japanese officers when they first examined the wreckage. They had seen a machine, but what they were really seeing was a civilization built for scale, the union of democracy, industry, and innovation. Now that realization burned brighter than ever. Japan's factories lay silent. Its cities were in ruins. And above them all, the silver silhouette of the B-29 symbolized both defeat and the dawning of a new era. An age where wars would be won not on courage alone, but on science and production. The dawn after the fire, when peace finally came, the surviving engineers who had studied that first wreck returned to their universities and factories. Some would later join Japan's post-war reconstruction, men like Hideo Itokawa, who had helped develop Japan's early aerospace industry. Their new mission was not to copy the B-29, but to learn from what it represented: precision, innovation, integration between science and production. And in time, Japan would rebuild, not through conquest but through technology. The same spirit that had once tried to match the B-29 in war would now power its own miracle in peace. The age of the superfortress had ended. But its shadow stretched across history, a reminder that in the fires of Tokyo, Hiroshima, and Nagasaki, the modern world was born. In the quiet that followed Japan's surrender, the once mighty empire stood in ruins. Its cities were unrecognizable, a flattened expanse of ash, concrete, and twisted steel. Factories that had once produced fighter planes, ships, and tanks now lay silent under open skies. The war that began with bold declarations of destiny had ended with the hum of B-29s over a defenseless homeland. For the Japanese engineers, scientists, and officers who had examined that first bomber wreck, the surrender brought a haunting clarity. They had seen the future years earlier, and they had watched it descend upon them in waves of destruction. The B-29 had not merely been a bomber. It was the industrial manifestation of American power, an entire nation's creativity, discipline, and abundance concentrated into aluminum and fire. When American occupation forces arrived, they found a Japan stripped bare of resources but still rich in talent and curiosity. General Douglas MacArthur, the supreme commander for the Allied powers, immediately set about dismantling Japan's war machine. Arsenals were emptied, ships scrapped, aircraft melted down. Research centers like Tachikawa and Nakajima were shut down or repurposed under strict oversight. But amid that disarmament, something remarkable happened. Instead of punishing the engineers who had once worked on Japan's weapons, the Americans often engaged them. U.S. technical officers, many of whom had designed or serviced the B-29s themselves, saw in Japan's scientists a potential ally in rebuilding a peaceful, industrialized nation. Captured equipment, blueprints, and reports, including those from the examination of the downed B-29, were shared with American and Allied research divisions. Japan's own engineers were invited to study American production methods, machinery, and management systems. They learned about mass standardization, supply chain efficiency, and quality control, the very mechanisms that had produced the bomber that once terrified them. Factories that once assembled fighter planes were now instructed to manufacture sewing machines, bicycles, and eventually cars. The Nakajima Aircraft Company, dismantled by occupation authorities, would later evolve into Subaru. Mitsubishi Heavy Industries, once the builder of the Zero fighter, turned its expertise toward civilian vehicles, ships, and power systems. Slowly, the same discipline that had once fueled Japan's war effort was redirected toward reconstruction. American occupation officials encouraged this transformation, recognizing that economic recovery was the surest path to stability. The B-29, once the symbol of devastation, indirectly became the teacher of Japan's rebirth. Meanwhile, across the Pacific, the B-29 program had also left its mark on the United States. The scale of its production had pushed American industry to its limits, introducing new technologies in assembly line precision, aerodynamics, and pressurization that would soon spill into civilian aviation. Within just 3 years of war's end, commercial aircraft like the Boeing Stratocruiser emerged directly from B-29 designs, carrying passengers instead of bombs. For Japan, the lessons of the superfortress were sobering but transformative. The engineers who had once dismantled its wreckage now understood that true strength came not only from weapons but from systems, from education, technology, and the power of coordination. Where once they had seen the bomber as an enemy, they now saw it as a blueprint for progress. In 1947, as Japan drafted its new constitution, Article 9 renounced war entirely. The same year, former aircraft plants began producing components for civilian export. Each shipment, each machine part, each retooled factory represented a small but significant victory, not of conquest, but of resilience. The American occupation became not just an exercise in control, but a shared lesson in modernization. For both nations, the war had revealed the terrible cost of total conflict and the necessity of building peace on innovation rather than fear. The hum of the B-29s had faded from Japan's skies, but their influence had not. They lingered in the memories of those who had seen them, and in the ambitions of those determined never to be caught unprepared again. By the late 1940s, Japan had begun to change in ways no one could have imagined during the war. The bombed-out streets of Tokyo, once filled with rubble and ashes, became construction sites. Workshops reopened, factories retooled, and deep inside those same facilities where engineers had once studied the wreckage of a B-29 in disbelief, new machines began to hum, not to build weapons, but to build a future. The American occupation authorities understood something profound. Rebuilding Japan meant rebuilding its capacity for precision, efficiency, and technological excellence. And who better to lead that transformation than the very engineers who had once been humbled by American innovation? In 1950, General MacArthur authorized Japanese firms to resume limited aircraft research, this time for peaceful purposes. Many of the same scientists who had analyzed the B-29's alloys, engines, and systems now applied their knowledge to civilian industries. They developed automobile engines, factory robotics, and industrial materials inspired by the same principles of integration and durability they had once seen in that bomber. The lessons of the wreckage became almost legendary within Japan's new industrial culture. Younger engineers were taught not just about metallurgy or aerodynamics, but about what the B-29 symbolized: coordination between science and production, the power of standardized design, the efficiency of mass production, the importance of quality at every stage. In universities, professors reference the B-29 when explaining why Japan must never again fall behind technologically. In factories, managers cited it as proof that precision and discipline could achieve the impossible. And in boardrooms, executives looked to America's wartime mobilization as a model for Japan's economic revival. By the mid-1950s, this mindset bore fruit. Companies like Sony, Toyota, Hitachi, and Mitsubishi emerged as global symbols of reliability and innovation. The same engineers who once marveled at the B-29's centralized fire control systems now designed Japan's first transistor radios and fuel-efficient engines. The world took notice. Ironically, many of the technologies that defined the Japanese economic miracle had roots in what their engineers had once studied out of shock and desperation. The precision machining that once produced zero fighter parts now produced tape recorders. The metallurgical techniques once used for aircraft wings now strengthened car frames. Even the concept of continuous improvement, later known worldwide as Kaizen, echoed the relentless pursuit of perfection that American wartime factories had mastered. Meanwhile, in the United States, the B-29's legacy continued in a different form. Its advanced systems and operational experience directly led to the B-50 Superfortress, and eventually the B-52 Stratofortress, an aircraft that would define the Cold War. The philosophy that created the B-29, large-scale engineering, global logistics, and scientific collaboration, now powered America's dominance in aviation, space, and nuclear deterrence. Thus, the technological rivalry that had once defined the Pacific War evolved into a partnership of progress. Japanese engineers began working with American companies, exchanging ideas and designs, Factories that had once been targets of bombing raids now produced components for American industries. The shock of the B-29 had turned into respect, and eventually, into collaboration. By the 1960s, Japanese scientists and industrialists openly acknowledged what they had learned from the war. Dr. Hideo Itakawa, often called the father of Japanese rocketry, once remarked, "We learned not only from defeat, but from the machines that defeated us." It was a quiet truth shared among a generation that had seen their country reduced to rubble and rebuilt it with discipline and humility. The echoes of the Yae superfortress still lingered, in the roar of Japan's new jetliners, in the hum of automated assembly lines, and in the national commitment to mastering the science that had once brought them to their knees. The B-29 had been a destroyer of cities. But in a strange, undeniable way, it also became a teacher of nations. The war had ended. The smoke had cleared. But its lessons, written in steel, sweat, and sky damikantrin, in the decades that followed, the story of the B-29 wreckage faded quietly into history books, a brief episode in a vast and terrible war. But for those who had been there, the Japanese engineers, the American airmen, the factory workers on both sides of the Pacific, it remained something more. That shattered aircraft had once embodied the imbalance of two worlds. On one side, a nation stretched thin by war, struggling on limited resources and tradition-bound methods. On the other, a country that had transformed industry into art, harnessing science, democracy, and mass production into a single unstoppable force. When the engineers in Tachikawa traced their fingers along the riveted skin of the B-29, they weren't just examining metal. They were touching the future. They saw in that wreck the cost of isolation and the power of innovation. Years later, as Japan's skies filled once again with the sound of aircraft, this time passenger planes, not bombers, that lesson lived on. Factories that had once built machines of war now produced cameras, electronics, and cars that would travel the world. The very precision that once sought to imitate America now rivaled it. And through that transformation, Japan reclaimed its honor not through conquest but through craftsmanship. The B-29 in its time symbolized domination. It could cross oceans, fly above storms, and strike with impunity. But history is full of paradoxes. The machine that once brought fire from the sky had, in its unintended way, kindled a light of renewal. From destruction came design. From defeat, discovery. And from a single wrecked bomber on a hillside in Kyushu came a silent understanding that would reshape a nation. That true strength is not in weapons alone, but in the minds that build them, and in the courage to rebuild after they fall. In that sense, the story of the B-29's wreckage is not one of humiliation or revenge. It is a story of awakening, of two nations learning, in different ways, that the future belongs to those who innovate, and to those humble enough to learn from what once destroyed them.